Well, maybe that's why I don't know it. Okay, guys. So what we're looking at next is something called surds, but you might have known it by a different name, also called radicals, especially if it was an American syllabus you were studying, or square roots.
Yeah.
You know, they're all the same thing. So surds, square roots, radicals, they all mean the same thing. So the lesson is not too difficult. Again, like yesterday's lesson, it's kind of just basic stuff here. But just to be clear, when I say surds, it's things like this. This is what I mean when I say surds. Okay? So you might want to write that word down, especially if it's a new word. Has anybody seen this word before?
Yes.
Is what you used in class?
Yes.
Yeah, okay.
So you don't use the word root?
I know we do. It's a bit weird, but it's like this part here is called the root.
Yeah.
But the whole thing is called a surd. I know it's a bit strange. And root is only short for square root, which is the full name for it. Okay, so that's just a little bit of vocabulary. So what we're having a look at today is just some basic rules on how to work with surds. So the first thing we want to see is how do we simplify, let's say something like this, 650. Yeah, so if we can just write this down and then I'll show you my process I have for simplifying this. There is a way to do it.
Without calculator?
Without calculator, yes.
Yeah. You make two numbers inside that get multiplied by each other. And then
Yeah, I actually have a different way.
I wanted to ask you, do we do fraction surds?
Yes, we'll have a look at those later. Yeah.
And then we add and subtract them? Or
Yes, all this type of stuff, yeah. We'll just start with this to begin with. So I just want to remind you of something which you would have learned in primary school, elementary school. Prime factorization tree. Do you remember this in school? I'll show you. So for example, if you had something like 120, you can say this is 12 times 10, and this is 6 times 2, and this is 5 times 2, and this is 3, 2, and this is all. So you can say 120 is 2 cubed, 1, 2, 3, times 3 times 5. I'm just reminding you of this. I am sure you've seen this before. I remember this from elementary school, so I'm sure you've seen it sometime in your life. Yes, maybe you didn't know its name, but we call it prime factorization tree. And we did this word yesterday, factor. So these are called factors. Yeah. Okay, so I'm going to use something similar to this to help me here. So what I'll do, I'll take 650 and I'll factorize it. So I can see that's 50 and 13.
13.
I think so.
Yeah.
Now you can choose any numbers. I'm choosing bigger numbers so I can do it quicker. 50 is 25 and 2, and 25 is 5 and 5. 5 and 5. So we have here that 650 is square root 2 times 5 squared times 13. So you care about the squares here because for square root you're allowed to split. Root 2, root 5 squared, root 13. This one can be simplified. 5. And I can put these two back together again. It'd be root 26. So 5 root 26 is the answer here. It's as simple as I can make it. I'll do a couple more of these and then we'll look at different types. But as our first example, if you can write this one down, please. So this is the first one. From here to here, is it? Yeah. What I did was square root 5 squared is actually 5 because the square root and the square cancel. So that's how I get this. And then root 2 and root 13. Root 2 and root 13 is root 2 times 13. There's nothing else I can do with it, which is how I get the 26 here. Where's my... Yeah. Okay, another example. Do you have this?
Yes.
Yeah. Okay, next example. We'll say root 693. Okay, 693. Well, I can see that 3 goes into it 131 times. And 131, 11 goes into it? No, not 11. No. 121.
231. Like, no,
Oh, so sorry. Yes, 231. Yeah, 231. Oh, and 3 goes into this again.
In 77.
Let's see, 77. Yes, and 77 is 7 and 11. Yeah. So this is root 3 squared times 7 times 11, which is root 3 squared root 77. So there's nothing I can do here. 3 root 77 is the answer here. Okay. And in fact, your calculator, you can check the answer. Now, in the exam, true, the calculator does give you the answer, but in the exam, you can only get the marks if they see some work here for this type. Okay. So no shortcuts for this one. Yeah.
Are we able to use our calculator in our first semester exam?
Yeah, but some of the questions like this one here, you won't get the marks if you did it only on your calculator. And the question will usually tell you this. Yeah. Okay. Let's have a look at another type now. Can I continue down? Yeah. Okay. Right, so as our next example, let's say you have something like this, root 250 minus root 10. Now I have bad news, this is not root 240. Okay, it's not. It doesn't work like that. So what we can do is we can simplify each of these. 10 is 2, 5. Well, that's not really useful. 2 times 5, that's still 10. Maybe we can do something here. 250 is 25, 10, which is 5, 5, 2, 5. Yeah. Now, I will group them by squares. So I'll have a 2, a 5 squared, and another 5. And the reason I group by square is so that I can do this now. It'll be root 5 squared, root 2, root 5. Well, what's this part? This one? 10. And this one? 5. Now you realise, oh, now I can put them together because I have 5 root 10 minus 1 root 10, the total being 4 root 10 then. Yeah. Okay, so again, write this one down, but it's the same idea as the last example. So we'll look on to a more difficult one maybe now in a minute. If you can write this one down. I think I'll do one more of these, but I'll let you try it first before I do it, because I think you should be getting the hang of this. Let's say something like root 896 plus root 224. Got it, Jeff?
Yeah.
Okay. Nearly finished? You finished, yeah? Alright, can we do this one now? Let's have a look. Okay, let's see. 896. Does 4 go in? Can we do 4 and that'll be 2,
4.
2, 4, yes, and then again, well, 4 is 2, 2, and 2, 2, 4, well, that's definitely going to be a 2, and 1, 1, 2. 1, 1, 2, hang on, let me think, 28
We can
times
leave the
4.
1, 1, 2. Because
Oh, because of this one here, yeah. Yeah, actually, that's true, we should maybe be looking at this one at the same time. This would be 2, 1, 1, 2. Yeah, and 1, 1, 2 is, what's that, 28 and 4, and 4 is 2 and 2, and 28 is 14 and 2, which is 7 and 2. 7, 2, 2, 2, 2, and here 2, 2, 2. Whew, 7 and 4. Yeah, isn't it? Yeah. 2, 2, 2, 2. My goodness, 2, 2, 2, 2, 2, 2, and 7. Right. Okay, so 896. It'd be root 2 squared. Tick, tick. 2 squared. 2 squared.
So it's actually 2
Don't confuse me. 2 squared. 2 squared. 2 squared. One more 2 and a 7. Yes. Okay. Plus root 2 squared. 2 squared. 7. Right. So this would be 2, 2, 2, root 14, yeah, 2, 7, yeah. Plus 2, 2, root 7. 8 root 14 plus... Oh, something went...
Or maybe...
I did something wrong.
Your mouse.
Oh! What happened? I feel like something went wrong. Did I miscount my... Ah! Look at this guy! Right here. Forgot about him. Alright. 2 here. Which makes this
14.
a 14 then. That's better. So this will be 8 root 14 plus 4 root 14. And there you go. 12 root 14 is the final answer. Okay, so if you can write this one down, and then we'll look at a different type now. So like yesterday, it's more just about mental arithmetic than actually problem solving. Do I need to zoom out, or
Yes,
it's okay?
please.
Yeah. Oh, Juan, I forgot to say, all these lessons are recorded. So the lessons from this week, you'll be able to see them on YouTube then. So all these are recorded then. Yeah. So you didn't miss anything. Okay. You have this? Yeah? Nearly. Okay. Okay, let's have a look at the next type now. Okay, so the next type will have something like this: root 8 plus root 3 times root 2 plus root 48.
No, thank you. I'm trying to go to this one.
Right, well, we can see that there's nothing we can do here. This is finished. This is finished, but maybe with the 8, that's 4 and 2. That's, come on, wake up. Give it a second, it's cold. Come on. There we go. 2 and 2 and 2. And then this one here, that's 4 and 12. 2 and 2, 4 and 3, 2 and 2. So 2 squared, 2 squared. So I'll just save time. I can see that this will become 4 root 3. And this one will become 2 root 2 when you do it. So my problem, I can at least simplify it a little bit by changing it into 2 root 2 plus root 3 times root 2 plus 4 root 3. And we just multiply like normal. So this one multiplies. That would be 2 times root 2 root 2. And then this one here would be 8 root 2 root 3. 2 times 4 and root 2 times root 3. Then this one would be root 3 root 2. And then the last one would be 4 root 3 root 3. But this one simplifies and this one simplifies. So this one becomes 2. And 2 times 2? 4. And this one is 3 with the 4, 12. This one becomes root 6 and this one root 6. So 8 root 6 plus 1 root 6, 9 root 6. So finally we have 16 plus 9 root 6 as the final answer then. Yeah. I've just multiplied them out one by one. So the first one I did was this one. Multiply this.
You multiply square root by square by the same square root.
It turns into the original. Yeah. Okay. Okay, so I'll do another one, but I'll let you try it first when you're ready.
Can you just draw the last thing?
Which part?
The last,
Which line?
yeah.
Here?
When you,
Here to here? Or here to here? This one? Yeah. So, root 2 by root 2 is 2. 2 by 2 makes the 4 here. And then root 3 by root 3 is 3. 3 by 4 makes the 12. Root 2 by root 3 is root 6. 2 by 3 is 6. And the 8 is still there. Root 3 by root 2 is root 6. And I just wrote a 1 here to make it clearer. I have 1 of these, but I have 8 of these. So in total I have 9 of them. Does that make sense? Yeah? Can I scroll down a bit, like here? Yeah. Okay. Okay, so when you're ready, please try this one and then I'll do it. Finished it? Yeah? Yeah. Okay, let's have a look at this one now. We should have it finished. So, the root... Come on. That's stuck again. So the root 2 we can't do anything with. But the root 135, the root 15... Well, the root 15 we can't really do anything either. The root 18 we could do something with. And the root 135... Can we do something with that?
Yeah.
27, 3. Yeah, we can do something with that. Okay, so let's see what we get. Oops. Too far. Alright. So that's going to be 27 and 5?
No.
No?
9 and...
Yeah.
Okay. 3 and 9.
Oh.
3 and 3.
Oh.
So this will be 3 root 15
Yes.
minus root 2.
Yeah.
Root 15. Now this is 9 and 2, isn't it? So 3 root 2. Okay. So let's multiply. That by that will make 45. This one by this one will make minus 9 root 30. Yeah. This one by this one is minus root 30. And then that one by the last one is 6. But a plus.
Yeah.
51 minus 10 root 30. Okay, I hope you got that. Now, if you think about what we've done so far, we've learned how to multiply, add and subtract surds. So this is multiplying, which we've done. Earlier we did, this is adding, and I think here's subtracting. So there's only one left that we haven't done, which of course is dividing. So dividing surds. Let's have a look at an example. So if I have something like 18 plus root 120 over minus 8 plus root 30. Yes. So who knows from, or who remembers, I should say, from high school perhaps, how to do these ones?
You actually multiply minus 8 minus root 30.
Where?
And the
Both the top and the bottom. So the trick here, the trick is to multiply the top by minus 8, nearly the denominator, minus root 30, minus 8, minus root 30. Now, some vocabulary first. Does anyone remember the name of this? Yeah, it's the denominator, but this is a special type of denominator compared to this one. Like, in other words, this is called the something of minus 8 plus root 30. Not reciprocal. The parallel of minus 8 plus root 30. No. The canceller. No. Anyone else? It is a C.
Component. No.
Not component. Not composite. Conjugate. So this is called the conjugate of minus 8 plus root 30. So in other words, the conjugate of A plus B root C is A minus B root C. Okay. And there's this trick here. We'll simplify it. I'll show you in a moment. But does anyone know the verb? The verb for doing this trick?
Conjugating?
No, but it should be. Not conjugating, believe it or not. Rationalizing. Yeah. This is the verb. Yeah, so there's lots of vocabulary here. Maybe some of it's new. So before I do it, I want you to write these vocabulary items down.
So what's the rationalizing?
It's the verb for this process. So if somebody said rationalize this, it means to multiply by the conjugate.
Because the surds are irrational numbers, so you're rationalizing.
Yes, that's the idea. Yeah, that's it. So it does make sense why it's this word, yeah. Okay, so just write down this vocabulary and then we'll have a look at this. So I'll just write it again here. Okay, can I do it now?
Yes.
Yep. So before I start, let's simplify a little bit. So this will be 18, okay, 120, 4 times 30, 2, 15. So, yeah, 3 and 5.
No.
I think it's just going to be 2 root 30 over minus 8 plus root 30. So there's not much simplifying I can do. Now we'll multiply. So the first one is, I'm tired, 18 by...
144.
Are you sure?
Yeah.
You're right. Minus 144. And then this one, there's nothing we can really do. Minus 18 root 30. This one is minus 16 root 30. And then the last one is
Minus
60 when you multiply them. Now something interesting happens in the bottom. So minus 8 by minus 8 is 64. Minus 8 there is plus 8 root 30. That one will be minus 8 root 30. And finally,
It becomes
minus
any
30.
factors of the top and we cancel them.
We can, yeah. What happens here? Do you notice how these cancel?
Yes.
Yeah.
This always happens. It should always happen. That's the whole reason for using the conjugate. It wasn't an accident. On the top we have minus 204 minus 34 root 30, and on the bottom we have 34. Now I think both of these can be divided by
Minus
34.
6.
Yes, minus 6 minus 1 root 30. And this is the answer. Not easy for sure.
Can you repeat the second stuff?
Which one now? My multiplying.
No, fine.
This one.
Like from the first one to the second one.
Here to here.
Yeah.
The only thing I did was the root 20 can become 2 root 30. And this is the conjugate. And then I start multiplying. So there's 4 multiplications on the top and 4 on the bottom. So you just do it one by one. There's nothing too special here.
I have a question.
Yeah.
During the exam, do we have to show the working of that?
Yeah, for this type of question, if it was in the exam, what they would need to see, well, what would probably happen is they'll get a mark for seeing that you know to use the conjugate.
Yeah, but for when we're like dividing, top right.
Oh, here to here?
No, over there when you were dividing 120.
Oh, simplifying the one,
simplifying,
yeah. In the exam, they're not fussy about that. You could go, for this problem,
Yeah.
they're happy for you to do what I did and just go straight to that.
So I can use the calculator to find.
For these types, yeah, they don't need to see this tree. But they will need to see a conjugate. And they will need to see evidence of multiplying. Okay, let me give you one like this to practice, and then I'll let you know what the homework is. Can I scroll down? Yeah. Okay, so try this one for me. We'll say 82 plus root 14, 4 plus root 14. Okay, try this. 82 times 4 isn't that bad.
328.
Thank you.
He finished it.
Yeah.
Okay, let's have a look then. So, the conjugate here is 4 minus root 14, and here is 4 minus root 14. Can we simplify root 14? No. Right, so let's start multiplying. So on the top I have 82 times 4, which is 328, is it? Yeah. And then 82 minus 82 root 14 plus 4 root 14 minus 14. Yeah. 4 plus 4 root 14 minus 4 root 14 minus 14. So on the top I'll have 314 minus 78 root 14 over minus
Over
10?
Over 2.
Over
16 minus 14. 16.
Oh, so sorry, thank you. That should be a 16, yeah, thank you. So here is 2. So that'd be 157 minus root 14 then. This is the answer then, here. Okay. So, just a matter of practice. That's all there is to it. Let me tell you which ones to try now. We'll just say 1 A, B, C, and then 2 A, B, C, X, and then 3 A, B, and 4 A, B, Y. Okay. So this is what the homework would be. But you can start it now for a few minutes before we go on to the next topic. Okay. Oh yeah. So let's just have a look here. All right. Oh, I'm logged in, of course. Let me just open up a new window. Right. What's your email? If you can put your email there.
when you get your account on the network.
Oh yeah, I'll get that.
I'm from Iran. And you? Oh,
What?
Malaysian.
Oh, nice.
What's your password? Your date of birth? Yeah.
Yeah.
And then this one. Yeah.
Now speaking Malaysian.
See that again? Yeah, just put it here. Just type it there so I can see it.
Yeah, I'm from Intisari Penang.
Okay.
Just for
Oh. Yeah, I see. Okay, let's have a look for your account.
open this.
Okay.
Let's have a look. Okay, so your email address was it here? It's here, right?
Now what's your name? Sanna?
Yeah.
Can I call you Tintin? Tintin.
Okay, is this right?
Yes.
Right, so maybe it's your
Jannah
date
or
of birth.
Jannah?
So try your date of birth again.
Oh, okay, Jannah.
Yeah, we'll just save it.
Jannah is fine. Faisal.
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 Can I close this? Did you write the questions down you need to do?
Yeah.
Yeah, okay.